If all you do is write down these definitions as you're reading this text I'm going to pass out here in a little bit, you're not going to get what I want you to get from this. What you're looking at here is something called AM, amplitude modulation. You'll learn more about that. And it's a way of transmitting radio signals. You're going to look for, in the reading I'm going to pass out, how do we prepare the sound that the DJ makes when he talks into the microphone, that he gets from the CD player. How do we prepare that in a way that we can send it over long distances? And then how do we receive it on the other end? How do we pick it up and turn it back into sound? That process, AM radio, does something called amplitude modulation, and I'll be talking about that a little bit later, and you're going to read about it. These four things here are parts that are found in a basic AM radio. We're going to take one out tomorrow and we're going to listen to it. Dress accordingly, okay? And hopefully you'll be able to hear some AM radio and realize just how simple it is. These symbols, you learned some schematic symbols already. These are new ones to add. Those are the symbols that represent those parts. So as you read, look for how do we send out that signal? How do we receive it, and what does each part do? How does it contribute to getting that sound back in a way that you can listen to it, okay? When you get this, you are more than welcome to highlight, underline, write on it, all you want. This is your copy. You'll use this to complete the homework. I'm going to give you a brief little overview of this. So on this one slide, I have all the information about how radio is transmitted and received. And I'm going to walk you through this, so let me kind of describe what all these different blocks and symbols represent. And hopefully when we're done here, it's not just that you've got these definitions written down for the different parts, or that you have the symbols, which you certainly need to have those symbols, but you understand. It makes sense to you how this is working, okay? First of all, I got my radio guy here. He's talking into the microphone. He's playing a CD or whatever the case may be. He's at the radio station. So this little box represents the radio station, and this is the antenna that they use to transmit, send the signals out, okay? All of this stuff here represents the four main parts, actually five main parts, 1, 2, 3, 4, 5, that you would find inside an AM radio. It allows you to pick up what he's sending. This business up here is what is traveling through the air and reaching your radio. So I'm using symbols to represent things because, as you know, we can't see radio waves. And one thing that's kind of helpful, if you try to imagine this like sending a letter. If you want to send a letter from one place to another, you have to do certain things. You have to put it in an envelope. It has to have a stamp on it. It has to have an address. And there has to be a mail carrier, a mailman or mailwoman, post person, that delivers it from one place to another. And we have many of those same things represented here. So it starts at the radio station. Now, if the guy wanted to be heard, or he wanted his music to be heard, he could stand on top of the radio station, face his speakers towards Tucson, and yell out of a microphone. Sound waves will travel a distance. They travel a lot slower than electromagnetic energy. How fast does this energy travel? Speed of light. Okay? When I said the speed of light was 186,000 miles per second, that's not just light, that's all of this energy. Now it travels at a slightly different speed when it goes through air versus in a vacuum. But for our purposes, 186,000 miles a second. That's going to go a lot faster and a lot farther than just standing up and yelling. Because you have to move air. Okay? Here we're not moving air, we're moving a wave of electricity, which is creating a wave of magnetism, and it recreates itself. At the top here you see I have two different lines drawn, one in red and one in blue. The carrier wave would be like the envelope. It's the thing that's going to allow me to get the sound from point A to point B, because that is electromagnetic energy. That's a radio wave. Now a radio wave with no sound attached to it would just be okay? You wouldn't get anything of use. What we do at the radio station is, before we send out this wave is sent off of an antenna, a hunk of wire. You've seen these antennas, Mount Bigelow, top of Mount Lemmon, out here off of Swan, all those big metal towers with the red lights on them. You guys know what I'm talking about? Okay? Some of them are radio, some of them are TV. TV does transmit using radio waves, electromagnetic energy. But what they do at the station is, you know, the DJ is talking or the music is playing, and there is a sound wave that's created. You guys probably see it on your computer when you play sound files, you know, and you get the little graphic equalizer thing where the different lines go up and down. How many know what I'm talking about? Okay, same kind of thing here. So the guy may be talking in, hello, Tucson, and you get a little pattern like that, a little wave. That's the sound that we want to send to the radio. But sound alone isn't going to make it. So what we do is we use a device called a modulator. And modulate, for our purposes, just think of change. Right now, I'm modulating my voice. I sound like many 8th graders whose voice suddenly cracks in the middle of talking. Okay? I'm changing my voice. I know we got lots of big words here. You need to pick that up. We got lots of big words here, but when you hear modulate, just think change. So now when someone says you want to listen to the AM radio, you can say, hey, you know what AM means? What does it mean? Okay, now you could say the words amplitude modulation and really have no clue what you're saying. Amplitude, okay? An amplifier makes things louder. When I talk about amplitude, I'm talking about the strength. The wave's low, the wave's high, the wave has more amplitude. Look over here where the wave gets a little bit higher. There's greater amplitude there. And you might have kind of seen what we're doing, how we're combining the audio, the sound wave, with the carrier wave. That's what we call this wave. Right now, constant tone. But if we modulate it, that means we change this. We use this to control this. This is like the director. It tells it when to get louder. It tells it when to get more quiet. So when it reaches this point here where it goes up, that tells that wave to go up. So that modulator, that device at the radio station, will change the carrier wave. And you end up with the black line. The red line is not really there. Because remember, the red line is just the sound. We can't send that sound the way it is. But we can change the electromagnetic energy, the black line. Do you see how it's similar but it's not identical? I mean, if it were identical, we'd have a lot better sound quality on AM radios. But it's similar. So we get some peaks that go up where those peaks are, and they go down where they go down. Now this wave of electricity, and sometimes it goes up, and sometimes it goes down, okay? Of electricity and magnetism. It's changing in its strength. Changing in its strength. It hits the antenna of your radio, which essentially is a piece of wire. That's the symbol for the antenna. The antenna acts like a net. We're hunting radio waves. Tomorrow we're going to go hunting for radio waves as well. We need a trap. Our radio receiver radio is the trap. It has these 5 parts: an antenna, a coil of wire, a device called a detector, an earphone, and a connection that goes to the ground. Every good trap has some bait. What is the bait here? If it was a mouse trap, it would be cheese. In my radio, what's the bait? No. Think you're an electron. What are you looking for? Where would you like to go? To the ground. Here's your bait right here. This connection is called the ground connection. And I want you to think of just kind of what's shown there. Here's the earth. We drive a piece of metal, a stake into the ground, and we hook our wire up to it. That's why that's the symbol for a ground connection. It's showing that metal going into the ground. Okay? So that's the bait. That's where the electrons would love to flow. By sticking a piece of metal up in the air, we have a good net for catching our prey, the electromagnetism. And here's where everything comes together. I think this is pretty cool. The electricity flowing makes magnetism, right? So I've got moving magnetism, and there's your wire. And moving magnetism passes through your wire. What's it going to create? Electricity, just like when we took a magnet and we ran the wire up and down through it. So now the moving magnetism going past my antenna creates electricity. The electricity wants to flow through that wire because eventually it's connected to the earth, to ground. All we have to do along the way is hold on to it long enough that we can listen to that sound and remove the part we don't want, which would be like opening the letter and throwing away the envelope. So the first part is the antenna captures it. Then it passes those electrons onto a coil of wire. Remember, when we wanted to make magnetism stronger, we wrapped it in a coil. Well, by putting this in a coil shape, it's going to hold that energy for us longer. It's going to be like a tank would hold water. This is going to hold our electrons. It's going to store the charge so we can listen to it. Next step. The electrons are passed on to something called a detector. Notice down here it says demodulator. Modulate, demodulate. Modulate means to change, and in the case of the modulator, we kind of combine those two into this. Demodulate, now we need to get rid of garbage. And what the garbage is all of this stuff. We just want the part that matches is closest to the audio. Are you with me? And all the stuff that flows negative, all of this here, we don't want. That's the envelope. We want to throw that out. The detector is a device that gets rid of all that negative part. Okay? Often we use an electronic part called a diode. This symbol you see there is the symbol for a diode. A diode is a detector. It's a thing that removes the negative in our crystal radio. Think of it as those one-way turnstiles. You know, you go through them and they click over and you can't go back. That's what they're going to do. They're a one-way gate. By the way, we use these when we changed AC into DC. Remember that? We use 4 of those to do that. So they're nifty little things. Now, a diode works as the detector. It does that job. There are other things, plain old rocks, that we'll talk about tomorrow, rusty razor blades that you read about if you got far enough in the reading, that can also do that job. But we'll talk more about that next class. Okay? So now we've gotten rid of the bottom, and we end up with something that looks like the top part here. That something then flows through our headphones or our earphones, and there's the symbol for that. And in our case, we're going to be using piezoelectric earphones. It's a little disc with quartz crystal ground up on it and wires attached. When we give that disc electricity, what does it do? Vibrates. And that's how we create our sound. And so as the electrons flow through, we hear that sound as they flow to the ground. Pretty simple, huh? Yeah. But it is actually. There's only 5 parts to this radio. We could add some more parts to make it better to tune in signals, to make it louder to hear. But the most basic AM radio only needs those 5 things. Okay? Now there is another little trick here. We need to be able to tune in one station and tune out the other. And the difference between one station is the length of the wave. You do see how these waves are longer than these waves, right? Well, you know that on the AM radio dial, you have 790 and you have 1490. In 1490, it's 1490 kilohertz, thousands of cycles every second. Okay? For 790, you have fewer of those occurring every second. There is a way that we can tune out one and just listen to the other. And the way that's accomplished is by changing what we call the resonant frequency. Don't get hung up on that word right now. I want you to just picture this in an illustration. We change that frequency that we're trying to tune into by changing the length of the antenna wire. Longer the wave we're trying to catch, longer the antenna we need. Shorter the wave, shorter the antenna, which is why your cell phone antenna is short and an AM radio antenna is long. But we can also change the length of our coil. I'll show you that in a second. Here's what this is accomplishing. See if you can see this up here. I'm using pendulums to represent the stations. Okay, I have two different stations here. The one with the longer string is a longer wavelength, like the bottom one. Okay, the one with the shorter string is a shorter wavelength. All of those waves are hitting your antenna, and the radio wants to hear all the stations at once. So imagine those waves like this. Okay, I pull these back and I let them go, and they swing back and forth. But if the wavelength is long, the frequency is short. It's slow. It's not occurring 1, 2, 3. It's not occurring very frequently. On this one, 1, 2, 3, 4. Do you see how it occurs more frequently? The longer the wavelength, the shorter the frequency. The shorter the wavelength, the longer, or the quicker, the higher, I would say, the frequency. This happens more frequently, okay? And what the radio does, by changing the length of the antenna or how many turns you have in the coil, it's like pushing a kid on a swing. You know, one kid is swinging like this, and another kid is swinging like this, okay? You're going to push them at a different speed, at a different time, depending on how fast they're swinging. You're going to time it, okay? Ready, push, 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 okay? Not very often are you going to have to push them on this one because it's a long string, a long swing. On this one, it's going to be push, 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 push. Do you see that? So if you're wanting to help out that particular channel, you're going to have to give it a push at just the right time. If you make this the right length and this the right length, it's like pushing it at the right time. If you push this at the wrong time, does that help or hurt it? Hurt it. So if I'm going to do the same thing to both of them, one of them I'm going to help and one of them I'm going to hurt. You see what I mean? I'm going to tune this one out because I'm trying to push this one at the right time. That's going to hurt this one. It's going to stop this one. It's going to help this one. So that frequency, that speed that swings back and forth at, is a set thing. It always wants to do it. It always wants to swing at that speed. All I have to do is figure out what that speed is, and if I push with it, I make it stronger. Okay? That's what we call its resonant frequency. It's what that wave wants to do. And we do that by changing the length of the wire. Now let me show you how that's accomplished. You can make these radios out of some very simple things. Here's one made out of a saline solution bottle like you'd use for your contacts. See how I'm going to change the length of my coil? Do you see that on the top here I have all these different turns and I have connections to them? Spit it out. I have connections along the top. If I connect my wire, let's say here, it's like making the coil this long. If I connect it down here, it's making the coil this long. I change the length of the coil depending on where I connect. Those are called taps. So I can connect to different points. It's like tuning in a different station. Another way I can do it, if I'm using enameled wire to make my coil, is I sand off the covering. And then if I make my connection like I am with a paper clip here, I can tune in different radio stations by changing the length of my coil. And that's precisely what you're going to have on yours tomorrow. You're going to use a little alligator clip and you're going to touch at different points along this strip that I've sanded off to change the length of your coil. All right? Now, you should have all the parts, you should have all the definitions, you should have all the symbols, and hopefully at this point know how they work, know how we change our station. I want to show you a couple other things before I give you the homework assignment, because it illustrates how this is accomplished. You know, yesterday I talked about light and radio waves and all this different kind of energy, and I told you that they're all the same. The only difference between light and radio waves and X-rays is how long the wave is. That they're all electromagnetic energy. I know you don't believe me. I know you think radio waves are something totally different from light. You can't see radio waves, you can see light. Therefore, they must be different. Well, would you be impressed if I could transmit sound through the air using light?
Yes.
You should be. It's kind of a cool demo. Let me show you what I've done. Over here, I have a little laser pointer. I'm going to turn off the lights for this demo. I have a little laser pointer. It's not on right now. I'm going to go ahead and plug it in. And if you look carefully, you can see that there is red light coming out of there. In fact, you might be able to put your hand up back there, Zach, and intercept it somewhere.
Where?
Why don't you stand up, see if you can find the light. You got to reach up with your hand. Wave your hand across so you see it. Oh, too short. You got to get closer.
Wait, I can do it.
No, you can't.
Come on.
Okay, this beam of light that's traveling over your heads right now is actually carrying sound. It's carrying audio. Think about it. What I needed was something to carry it over long distances. Light does travel, can travel, particularly if it's a laser pointer, can travel a long distance. I needed something that I could change the strength of. Remember, we call that amplitude modulation. Modulate means to change, amplitude means the strength. And this light, even though you probably can't see it, you can see it on the wall back behind you there, is actually flickering, ever so slightly. It's getting brighter, it's getting dimmer, because it is plugged in to my headphone jack through a little transformer here. We talked about those. And that transformer and the battery are changing how bright that light is. So let me finish here, okay? It's changing the brightness of this light. Then all I need to do on the other end is point it at something that can turn that light back to sound. And that something is solar panel. You might recognize the solar panel that's up there. Solar panel converts, light back to electricity. Now you don't hear anything yet because that solar panel is hooked into a little speaker. And if I turn the speaker on, we'll see if you're getting it. Why do I need the lights off?
It doesn't change
You're right. Get confused. We call that interference, right? When you listen to a radio, you get interference because there's lots of other electromagnetic energy around. You run your blender, the TV, all these other signals are bouncing around out there, and they all cause static. In this case, the static would be light in the room. So now what I need to do is line that up right until I get a good connection. Playing the CD over here. And if you don't believe that that's coming from the light, okay? And the cool thing about this kind of transmission, I am using the light. I'm modulating the light. The cool thing about this transmission is that the only people that will hear it are the people that intercept that light. In fact, you can intercept it along the way. Matt, stand in front of your chair there. And find the light, lock it with your hand. Okay, good. Now, put this in your ear. And I've just got a little setup here with one of these little sensors that go on those little night lights you put in that come on at night automatically. That's one of those little electric eyes. And it will turn the electricity. It'll actually resist more or less depending on the amount of light it gets. Okay? So it's intercepting that with just this battery, one of those little sensors, and a couple of resistors. I plugged it in. It goes through a little transformer, Anthony, and then it goes to a battery. So the battery's supplying the electricity for the light, and the transformer's hooked up to the stereo. So as the intensity changes in the music, the intensity of that light changes.